get certain restrictions I'm still under. So anyhow, we'll see if everybody can see this, and I'll put this in the slide. Ben Foster, who is with me tonight, tomorrow, as I said, will be with the city. Will be helping me out tonight, and I wanted to just tell you that Ben has been quite instrumental in helping me out over the last few years. Well, he's always been instrumental since he started the firm, but over the last few years, I've had a couple of medical speed bumps, and he's been quite helpful to me in the city of Minneapolis as well. He's doing double duty. So.
He's trying to blame this project on me, but I'm not going to let it.
Yeah. So, and I'm going to be walking in front of you guys a lot here, but there's a lot of people in the room that worked on this project as well. Okay, and they had very important roles. Bob worked for the low voltage contractor, was instrumental. Skyline Fire Protection. Gordy's here from the city. Worked on it as well, and of course Ben, and I probably forgot somebody, but there's a lot of people that helped pull this whole thing together. We started this project back in, actually we were contacted by HGA, they're the architect of record. We were contacted by them back in 2000, and they said, we're working with a design consultant out of Switzerland called Herzog & de Meuron, and they've been hired by the Walker to come up with a design concept for the expansion of the Walker Arts Center. Now, order of magnitude, of course, Chris was involved with this project also, because at the time he was with the city of St. Paul, he would provide technical assistance to the city of Minneapolis on a contract basis to go over some specific area where we were proposing some alternate methods of protection, particularly as it pertained to protecting columns and sprinklers and move past fire protection. So he was instrumental and was involved in this project as well. When we first got involved, it was kind of like this, because I sat down with the architect from, or design consultant from Switzerland, and he asked me, is it okay if I could put 400 people in a gallery and have one exit? And I said, well, that would be very difficult to do. And then he said to me, he showed us some fairly radical designs that he wanted, large open areas that would go through firewalls, very unique exiting. And when we told him that we have codes and regulations that we have to follow, and I had to send him chapter 10 out of the building code on egress, to say, here, start to read a little bit of it before you come back to us, because everything that we're sending to us was rejected. I felt like this at times, that this is what we were ending up with. But it was a fascinating project, because we worked from the early stages in the codes and code consulting all the way through to the end of the project. That's one thing I will tell you as a lesson that I learned, that we always wanted to try to make sure, and I think this is for any fire protection engineer who works on the design side, try to work all the way through the project at the time they issue the certificate of occupancy. And that's a lot easier said than done, because a lot of times the engineers get hired only through a certain phase, and then when they get into construction, they're out of the project. And we think that it's a tremendous quality assurance tool, that if you are doing performance designs and alternate methods and some strategies that really need to be documented, that you need to carry it all the way through to the end. Because things happen along the way, and something that might seem to be fairly subtle may have a drastic impact on the design assumptions or agreements and things that you put together in the city. Okay, so we're going to talk a little bit about project history, a couple of the key strategies, because we don't have that much time tonight. I want to get you out here before 11, and we're going to talk some of the requirements. I'm going to talk a little bit about integration to the design process. Ben's going to go through one of the mock-up testing that we put together for both some of the detection systems. I've got Bob here as well, so he can chime in on some of, because he was part of that mock-up testing. And then some of the special inspections, not only of the alternate methods that were used on the project, but the smoke control systems. And, along the way, it was a pretty good collaborative effort between, putting together strategies and then working with the alarms, Bob's firm over at Skyline. I mean, there was a lot of people that had a lot of constant dialogue to try to make some of these things work. Okay, well, the Walker, how many people have been by there lately? Okay, this is a picture viewing west. Okay, this is from Hennepin Avenue, and the expansion on your right is the existing building called Barnes. Okay, and the expansion headed south, which is the more silver outline, as you can see there, and it included a area they called the town square, and there were galleries back behind here. This was a circulation area, and it had we called this a performance box, and it had several levels. Was what, 8 levels, I believe? 7 levels, and then it had an assembly space on the top, and then it had a small theater that seated about 350 people. And it has a restaurant, and it has a bookstore, some of those types of things if you've been there. But then it had a large gallery and circulation space they called Town Square. Then, of course, we had the existing Barnes building, which was actually about 9 levels, and some of the galleries, if you've been in there, it's like a pinwheel that goes up through the building. Now, the design architect, right off the bat, said, we want to have a lot of openness between the existing building and going into the expansion. And one of the first things you look at, well, I have an existing building that was built back in, I think, 1970 or so, and you end up to have something open, you have what's called a firewall. Well, if we didn't put in a firewall between a new and existing facility, we would have to bring the Barnes building all the way up to current code. And one of the things the city of Minneapolis said to us was, well, we knew the building was compliant at the time it was built. However, in this day and age, can you do something that can help us make the building better? And so I remember that was Brad Thorson, I believe, was in that meeting, and I said, Brad, define better. He looked at me and he said, well, Mike, you're the professional, you tell me what's better. So what we looked at conceptually then with the Barnes building and the expansion, we took provisions out of both the covered mall and the high-rise package. And we bundled select things out of those so we could come up with a strategy that we thought that would make it a very safe environment and employ some of the techniques from both of those that we felt would be applicable to this project. The site is, again, as I mentioned, you have Hennepin at the top here. This is looking down, and then you have your, this is Vineland Avenue, and then this is Groveland Terrace. There's a parking structure, underground parking structure that also went along with this project. Interestingly enough, that parking garage was built separately, but yet was integrated with this project. And we used a concept called non-separated uses, so we did not have fire separation between the parking ramp and the new construction in the traditional sense. Conceptually, that red line shows you sort of what we call a demarcation. This is kind of a flipped up around drawing, but on the right again, the Barnes building, and on the left, the expansion concepts. And with some of the design parameters that they wanted to have for functionality in the space, we had to look at a couple of alternate methods. Well, what were the big things we looked at? Well, they had some structural look that they wanted to have to some of that glass that you can see with the lights up above there. They wanted to have a look where they have these very thin columns, and they didn't want to put passive protection. They didn't want to use intumescent paints. So we talked to them about a strategy where we could, in addition to just normal sprinkling of the building, that we would come up with a strategy where we could wet columns with water. And we would have to design in certain safeguards. I'll let Ben go through a little bit more of that in detail. But there were select areas where we wanted to do that. We treated the gallery space as a wall, so we put in smoke control provisions there where we would use what's called the purge or exhaust method, which basically purges the space, and we would exhaust the common gallery area as one zone, tripped by smoke detection of some sort in there, right, Bob?
Yeah, detectors.
Yeah, okay. And then we had 3 openings into the existing building. They wanted these large communicating spaces through this firewall, but they didn't want fire shutters. They didn't want anything that would restrict this beautiful view that they wanted to have between the new and existing facility. So we ended up using what's called the airflow method, where we would, depending on the fire scenario, whether the fire was in this structure or this structure, we would have air flowing in a direction of 200 feet per minute so that we could restrict some of the smoke byproducts that could spread from one building into the other. And in addition to that, each of those openings had a water curtain as defined by NFPA 13 across those openings. So we had closed space sprinklers across those openings that were dedicated separate systems from the other coverages that we had in the building as part of this maintaining the separation. So we had airflow and we had sprinkler coverage. And then as far as the Barnes building was concerned, the ownership had a real aversion to sprinklering that building because they felt of all the gallery contents that they had. They were very concerned about that. But interestingly enough, they weren't opposed to sprinkling the expansion, but they were adverse to sprinkling the existing building. You can kind of read into that any way you want. A lot of times it comes down just to money. So big picture, we ended up taking the building with several equivalencies. We had to analyze the exiting of the Barnes building, the level of protection, and we came up with a strategy there where in the existing building, we required then to upgrade it to make it better. We put in early warning detection, voice communication. We wrote up an operational plan with using guidelines that the fire department gave us, which would restrict fire loads, the types of materials they could put in there. We did an exiting study, a timed exiting study, to figure out if we could get the exits to flow properly and how long it would take to evacuate in an emergency. We also put in fire department communications, and then a very specific inspection, testing, and maintenance program and emergency evacuation plan. So we tied all that together to work with in the Barnes building. Now, later on, we're going to go through a specific challenge of getting some of the smoke detection in the Barnes buildings because of some of the construction. If you take a look, how do you analyze a fire load in a gallery? Okay, and part of the challenge is when you start looking at some of these galleries, some of the galleries would have, an inconsequential fire load. Others, where you can't really see this a lot, but that's, I think, the flower boarding. Yeah. You could have a very high fire load. We don't know or can really anticipate what some of these places will actually do in the long run. But we did put some parameters on how we could use some of these spaces. And with the Barnes building, we knew, generally speaking, that the displays they were putting in there were generally spread out. Every so often they'll build sub-rooms and try some things. I know they have a couple that they put in there displays where you actually walk in an enclosed space and you see some projection on the wall. But they tend to be very creative. As I mentioned, it's a pinwheel. If you've been in there, it's like a pinwheel effect as you go up galleries, as you step up through, and you have a central core stair, and then you had some exits stairs on periphery. Most of the people, of course, would use that central core stair or elevators in the center to circulate through the building or evacuate. Now, if you see here, this is going to be part of our problem. You see the T's, concrete T's. That was posing a challenge in terms of how we would put detection in the galleries. Or you can see what the problem challenge could be if we ended up attempting to sprinkler it. So one of the things that we wanted to look at, we could get SWOT detection in several areas, but in these galleries that had the concrete T construction, we ended up coming up with an alternate solution using a BESDA system. Problem is, of course, the galleries didn't want to run BESDA plastic piping through every bay of those T's. And so we ended up proposing to put it around the perimeter of the galleries and then coming up with some mock-up testing to try to verify whether or not we could get some sort of reading from that BESDA system, because the BESDA tubing was basically concealed behind a part of a pocket of a wall. It was exposed to the atmosphere, but it was kind of screened by a partial wall. So we ended up running some mock-up tests on that. You want to take a swing at that then? I can.
I sure can, Harold. Keep going.
Okay.
So, you know, looking at this mock-up testing, what Mike is saying, you know, we have the VESTA system around the perimeter. Bob, anytime you want to jump in on anything here. You know, as contractors, you've all heard this before, we look at doing something different than maybe what code would require. Spot detectors in each of these bays, really deep beam pockets here. So what did Gordy ask us when we're setting in a meeting? What does code say you need to do? Well, these smokes in each of the bays. We try to put this VESTA system around the outside. Well, the question came up, how is that going to perform relative to what code is going to require? Is it actually equivalent, since that's what we're proposing, equivalency, is it equivalent? How does it perform in relation to what code requires? The way that we came up to answer that is a mock-up. Actually install both systems at the same time, put smoke in a room, and see how they react. Actually come out with hard data and print out here, and with people standing there watching, when do these alarms come in, VESTA versus the spot smoke detection, let's see how they perform. Is it equivalent to what we proposed? So what we did was put the spot smoke detectors in one of these bays in 2 locations. Like, you go back one slide real quick. You see the spot smoke detection in these bays. And we got a theatrical fogger and set up 2 locations, one in between the VESTA pumping and the spot detection, and the other one was in between 2 of the spot detectors. So what we were trying to do was place smoke in a room, see which one is going to go off first, and measure the difference. If the spots are going to go off first versus the VESTA, is it a big enough difference for it to really make a difference to us? The answer in both of these was that the spot detectors went off before the VESTA did. And when the spot detectors out in the bays and more of them, of course they're going to go off. The smoke's going to hit those before it gets to the edges of the room. We know that, but is it enough of a difference to say that it's not equivalent? Well, the answer that we came up with in doing the actual field observation, actually putting smoke in the space, was no, the difference was not so significant that we could not proceed with the proposal of putting VESTA. And the city did accept that, did accept the testing, and go ahead. And this is just a couple of shots here of that actual mock-up.
See those beam pockets, how deep they are.
Yeah, these are really deep beam pockets here. So this is filling that space up with smoke, and this looks like probably in between the 2 spot detectors. So again, when we're in between those 2, of course, it's going to hit those spots before it gets out to the edges of the room to the VESTA system, but still, the VESTA operated with it way out on the edges of the room, so close to the spot detector activation that we were able to say the performance will be equivalent to what code requires, and justified it through actual field observation.
Let me just make one comment, then we'll talk about the structural protection. You know, there's always controversy or discussion about when you use kind of, smoke bombs or any kind of smoke. One of the difficult things is trying to replicate, the fire dynamics of, what would actually happen in a space. This is cold smoke. So as you can see, he's got Ben's got an extension on that tube there, and we're trying to direct it up at the ceiling. So the dynamics do change dramatically using cold smoke. But again, we were just trying to get a relative reference base, for this, since we were proposing this alternate. And again, going to the VESTA system, knowing its sensitivity level compared to a traditional spot detector, we thought that we would have advantages of using that and satisfying the need that the Walker Art Center wanted as far as the look. They didn't want all the piping or detectors. But it was important because mock-up testing was an important aspect to try to see, well, is our theory, within the realm of possibility. The next one that we're going to go through was structural protection. As I mentioned, that there were several areas where we were proposing using sprinkler coverage in lieu of passive protection. This has been used quite readily in different projects around the state of Minnesota and elsewhere. The city of Minneapolis has refined and put together some policies as it pertains to this. But we had to do a study of the space and study different scenarios to determine what would be the appropriate level of protection. And to assist on that, we were putting together some analysis, but to assist on that, the city of Minneapolis contracted the city of St. Paul, and Chris Cahill was involved a lot in this part of the project as well, to provide some input as to what are some of the technical things we should be looking at and some of the parameters we should be considering. And as an end result, we did come up with a strategy that we felt met the spirit and intent of the code and was a defendable plan that could be serviced and maintained. And so we worked collaboratively to try to come up with a strategy. As the engineer of record on the performance design, we still had to do the appropriate documentation, but we felt, given all the things that we had to deal with the constraints on the structure and the aesthetics, and then try to meet the fire protection guidelines, we had to work together as a team. And quite frankly, we have to try to make sure that we're not going to collapse a structure that is a type 1 fire resistant structure. Fortunately, there were some factors of safety built into the structural components we were looking at, so we knew we had some redundancy in the design. But again, to prove out some of the sprinkler techniques we were going to use, the city asked us to consider putting together a mock-up. And so we put together mock-up testing with the assistance of Skyline and our offices. We at Mortensen, we put together some mock-up tests so we could look at spray patterns to see if we were going to get the type of discharges we wanted to protect the structure. So Ben, I'll let you kind of go from there.
Yeah, before I take off on the structural, I want to go back to the detection for just 1 second and ask Bob. We've never talked about this, I don't think. Were you surprised at all of the results that even when we were in between the spot detector and the VESDA, were you surprised at all by the results that the spot detection still went off faster than the VESDA did in most scenarios?
It wasn't surprised because of the location of the detection and the air movement in the building, where, like you said, it didn't hit the edges of the building. The edges of the roof are the hardest thing to protect because you've got a curve, basically, a virtual curve where the smoke doesn't travel evenly. So we knew, we had done some tests before that. We had went through a lot of discussion. We were pretty positive the smoke detectors were going to go off, and you and I had talked about that. We were also positive that the VESDA would respond as well.
Right, and the VESDA too, how far down from the ceiling was that VESDA?
It's right in it, right there.
Yeah, it was about 3-4 feet down from the actual.
Right. Because you had a different weird airflow too. You remember the diffusers, the supply fuses were on the floor, and the return fuses were up through the ceiling. So it was almost a backwards flow, or it was another way around. Sorry, supply in the ceiling, and return way down on the floor. We had looked about putting the VESDA across the return air curl on the floor as it sucked up. We couldn't get enough air movement to justify pulling the smoke down. So, but it was real difficult to get in there because of the architectural, and we played around with copper piping, some different tubing materials. So, Art Olson was the hero in that one.
Yeah, Art did a great job. But again, we wanted total detection throughout the Barnes building because we felt early morning detection would help us get people evacuated and call in the necessary emergency responders. When we did our timed exiting studies, we felt that if we got prompt response, we could get people moving out of the building, particularly with the security staff they had and the voice evacuation system. A lot of the statistical data shows that we have a voice evacuation system combined with trained staff, we can get people moving more readily to leave the building. We wanted to get them moving out the door, but we had to balance the constraints we had with the owner's desire for a local legality.
They consider smoke detectors barnacles.
Yeah, well, they consider any fire protection a Barnard.
You scrape it off.
Yeah. All right, now we started talking about the structural protection. Again, this was an alternate method that was proposed, again, because the architect needed to provide 2 hours on the columns and didn't want spray applied fireproofing or intumescence. They wanted a certain look on the columns, and so that's when we employ active systems in lieu of passive systems. So that maybe one kind of.
Yeah, we had several areas where we used this active protection on the columns as well as some glass in some areas to provide the actual fire protection. And again, if anybody has any questions, fire them off at me. And Bob and Brian, if you guys want to jump in anywhere, Skyline was involved with the sprinkler aspect of this. And again, like the smoke detection, there was much discussion and tinkering with the ideas, tweaking this and that, and even down to part of the mock-up, just turning the deflector position a certain way. And that changes the whole design that you've been basing this project on for 3 years. Yeah, this goes back to I think the importance of actually observing your idea in the field, doing these mock-ups, and something can look great on paper. I think it's very important from code official side of things to contractor side of things for you guys to be comfortable that what we proposed and what you're installing is good and is going to work. Let's look at it, let's mock it up, run through some scenarios. For the steel protection of the glass, we had, like I said, several areas. Hennepin Lounge along here, we had kind of a unique situation where we had steel columns sandwiched between glass on each side, interior and exterior, in the middle of these columns. The columns required fire protection, and we were using sprinklers to achieve that fire protection. Now that presented a couple of issues. One, we had to protect the glass on the interior, and then the columns. How are we going to protect the columns when we had to put sprinklers in that dead airspace? And position those so that they're wetting the columns all the way down with sufficient water so that we can cool that steel and protect the glass as well. Go ahead with the slide. Now this is a shot of part of the mock-up. And again, Brian and Bob, if you guys want to jump in here, I know Brian was specifically involved this day on the mock-up. What we're showing here is an interior shot of one of the window sprinklers. And Brian, was this the WS sprinkler that we're looking at here?
Yeah, that's the
Yeah, okay.
sprinkler.
Great picture showing the sheeting actually going down the glass. The columns are on the inside.
Sprinklers are discharging it.
Yeah, can you, I don't
On this picture, if you can see that their sprinklers are discharging, and I think that this picture is, we've got them operating with the fire pump on.
Everybody got a link? Right at the top there, that, you can see it, it's coming down. You can see the sheeting action on the glass.
And so in this shot, we've got it running, we ran 4 different scenarios on the glass as well as the columns, both some high sprinklers versus some low sprinklers, some 90 PSI, I think that was with fire pump running, and then a lower pressure representing a sprinkler system supplied only by city pressure. That was one of the challenges that Skyline faced and had to meet, was designing this system so that in the areas of the equivalency, which were fed basically on their own system, so that you could shut off all the standard floor coverage and not affect these areas at all. All of these areas had to operate as intended based solely on city pressure. So fire pump fails, that's fine. We still meet the required flow of pressure. So we looked at that several different ways. Yeah, go ahead.
Did you set these all up as a deluge system, like alternates?
These were.
You're covering
Yeah,
all the
these-
flowers at the same time?
Yes,
Yeah, during the mock-up, they were all open, and there was, I believe, 3 heads. We ran it, and 3 were, then the same in different scenarios where we run both sides at the same time even at one point, or, I don't remember.
you know, I don't think that we ran both the glass and the columns at the same time. I think we looked at the glass separate than the columns.
Right.
They were in separate areas. We had columns in the dead airspace versus the glass on the inside of the building. But yeah, the bulb was taken out of these sprinklers. The water was turned on. We actually, Mike, if you go on to another picture, we're going to be able to see a little bit of the setup. Maybe not that one, that was a column. Well, here we had specific valves with a pressure gauge there so that we could regulate the pressure specifically to where we wanted it. With the fire pump running, versus strictly city pressure. And the purpose of this event, and the city was there, Gordy and a couple of other people from the city were there observing this. Were we getting the wetting that we said that we would get? Did it look like it was going to be sufficient? You know, we can run these fire models and come up with great ideas and put things on paper. But when we actually get out there in the field and look at it, you know, your senses are going to tell you, does it look like it makes sense? Is there enough water there to pull the glass, to pull the steel? And one thing we learned with this model WS sprinkler is the extreme importance of having no obstruction on the surface that we're wetting. In one of these pictures, you can see that we had duct tape to seal the joints on some plexiglass that we were using as the glass. And one piece of that duct tape had a little tab sticking out, and where that was sticking out, we had a big triangle come down that was just dry glass. The water hit that and angled off, and it didn't really come back together. So that's important. You know, I know that the manufacturer data sheet tells you warranty against the mullions and that kind of thing, but anything on that glass, between that sprinkler and that glass, will affect the sheeting action. Is going to, you're not going to get the intended effect of that WS sprinkler on there. That was something that was really good to learn on this mock-up, good to see. But again, we went through this this mock-up just to see, did what we said was going to happen, did it actually happen? Did we get water all the way down these steel columns? And the answer was, no, we didn't the first time, the way that we had it set up. And again, that's part of the reason for these mock-ups. We had to make a change, and we discussed it amongst ourselves there while we're looking at it with the city and with Skyline, and came up with a quick fix, and that was simply turn the sidewall sprinklers that we used from the deflector parallel with the steel to perpendicular to the steel, and that fixed the problem. Now we had a good spray pattern directing the water directly on the steel. We got wet all the way down, and that was the solution that we came up with, and again, just from this mock-up. And again, I'm stressing the importance of the mock-up. I think it is very important when you have these type of alternate methods of protection to actually observe, see that you're getting the results that you say you're going to get.
Just a note on that, when we say turn the deflector, it was a horizontal sidewall sprinkler in a kind of position to spray down the column.
Right. Yeah, we had it in an orientation that it wasn't even listed for in the first place. It was horizontal sidewall sprinkler. We had it installed in a down position, spraying water down this column. And then we took it and turned it so that the spray pattern was sprayed into the column on the one side and then the glass on the other.
This was our worst case scenario, because these columns in this area were, what, 20 feet or so in length. We had a couple other areas which were as critical, but we were trying to get that water to go down and as much as we could cover the column and peripheral areas. Is that a laser pointer?
I'm taking this home.
Ben, you mentioned you did the pressure, the flow testing at low pressures and high pressures.
Yes.
Did you notice any difference in the water quality? I mean, obviously the volume was higher at the higher pressures.
Right.
Were you getting more misting? Was it similar? Did you notice anything?
No, it was considerably different with the higher pressure. We were getting adequate sheeting on the glass and adequate wetting on the steel at the lower pressure. But when we looked at it with the higher pressure, you had noticeably more mist and the water particles that had sprayed back into other areas. So say part of the justification for WS sprinklers may be wetting of adjacent combustibles. See some of that. These WS sprinklers will give you wetting of adjacent combustibles, so that gives you added level of fire protection. We're going to wet anything that's beside the glass, so it's even better. Well, that's going to be true at these higher pressures. It had a lot of that spray back on the higher, not so much on the low pressure Drake City water. I don't think we saw
Not to the extent
too much.
Yeah, as expected.
And you were getting the similar, at least the equivalent sheeting action?
Sheeting on both the glass and the steel, with the WS on the glass.
That was a
The
prerequisite.
sheeting was adequate, so.
See, that ended up being a prerequisite of the design, because we knew that since we were substituting for the passive protection, we wanted to take the fire pump out of the equation, and we wanted to make sure any of these systems were still going to perform and maintain structure in the event we had a pump failure. Now, Bob and I had plenty of dialogue on eliminating failure points, and we went through a couple of things on the fire pump and some layouts and things, and we came up with what we felt were pretty adequate systems to minimize the chance of a fire pump failure, but it was a criteria that we had to use city water to make sure we could get the protection we wanted and keep these systems totally independent from the floor coverage systems.
And did you test with just one single head flowing, presumably to be the maximum peak pressure of the system?
No, they were all
They
over.
were all,
There was 3 heads on a line
Yeah.
at one time, and the gauge was a valve there to regulate the pressure for any entry when water in the pipe.
see on that other slide.
Is the actual installation of 12 heads?
Yes, it is.
Yes.
Okay, now you have 4 surfaces of glass, correct, with a steel column between.
That's right.
Actual installation, are you protecting 4 surfaces, 3, 2, or 1?
One.
That would be
The
the inside.
interior face of the glass is the only glass surface that we're intentionally protecting. And then if we're protecting the steel column in between the glass.
So there are no sprinklers in the cabin.
Not specifically for the glass, there are.
There are in the cavity for that, for the
in the
column.
cavity,
Yeah.
for the steel.
Yeah, we had to wet, see, one of the challenges we had, quite honestly, from my standpoint, you know, I can say it now because the building's up, I didn't really think we needed it on the glass. However, we had glass that was shielding these columns, and we had to get the shielding effect theoretically on those columns. Okay, we knew we didn't have the fire load really there that would compromise the system. But having said that, we were shielding these columns from getting any wetting action. And if there was a fire that started, you know, over the gallery space, which is over this area, down over in here, we needed to wet this glass so we would keep temperatures at a low enough point so that we wouldn't start elevating temperatures on that column. And we felt if we could wet the glass, we were going to prevent the temperatures from heating up those columns to a failure point. And the failure point we used was out of the building code. Gordy, I know he's going to, I think I characterized the position correctly, that we were trying to, because the glass was carrying cooling effects, if we had sprinkler discharge on the inside face, we would have to wait for the glass to shatter by the time.
And if the glass wasn't there, you'd have to have heads on the other side of the columns anyway.
Right. So, and as you can see, there was a lot of effort put in for protection, because the architect wanted to have a look on these columns that were sleek. I remember, I said, well, use intumescent paste, and they looked at me like, I just came to work with 2 different color socks on, which I usually do, kind of match it to them all. But they looked at me like, how dare you think of that? We want this race car finish, they said on the column. So, having said that, we ended up in providing the systems that would deem to satisfy the intent of the code, and Skyline had to come up and try to meet the performance targets that we had prescribed, which they did quite satisfactorily. So.
And one of the things that Skyline came up with, again, I'm going to go back on this mock-up thing, and having everybody standing there looking at the design that you came up with and put on paper, actually standing there beside it, looking at it, watching it operate. And after we did this mock-up and went and sat down and talked about what worked, what did not work, one of the things that had been specified in the original design were 155-degree sprinklers. And of course, we're trying to get these sprinklers to operate quickly in case of a fire. The Skyline says, well, those sprinklers are in a dead airspace behind glass, exposed to the sun. Are you guys sure you want to go with 155 with these column sprinklers in there? It's going to get really hot in there. Everybody's wow. It's been what, 3 years in the making, and now we get here weeks before it opens, and here we are. Again, importance of everybody sitting down talking about these alternate methods of design. Looks great on paper, 155-degree sprinklers, we're going to get activation really quick. And then our contractor said, yeah, but you're going to get activation really quick. So, good catch, Brian.
So we went with 550-degree sprinklers.
Well, I think we did it. And there again, it was,
But I do want to mention also that this design, like age opening protection, that type of thing, it wasn't just 3 sprinklers in the calculation, of course. It was a number of sprinklers. They were designed to operate to protect either the glass or the column, and that the sprinklers, while they're on a separate system, are balanced with the sprinklers that are in the adjacent circular space.
that's right, on the openings, we had sprinklers on each side of the opening, so we count, I think, both sides at the same time, plus adjacent sprinklers and balanced point of connection. And it's count out 6 ways from Sunday, I think.
How did you marry the design of the sprinklers and protection of the columns with the fire scenario? Maybe you're data modeling that.
We were going to spend a lot of time on modeling tonight because of time, but yeah, what we ended up doing, we looked at a few scenarios. We sat down with the city and with Chris. When I said the city, Chris was contracted. And we looked at different scenarios, design scenarios. We knew the fire loads were probably not going to be, very high in the gallery in this town square because there was much of a circulation space. So we looked at different design fires. We used T-squared fires, and we looked at some of the fire loads per unit area. And we did model where we would put the worst case and incredible scenario that we could go up with was a fire in immediate proximity of the column. Okay, and we did model those with slow through fast, I believe, T-squared fires, to try to see what would be the difference between different growth rates and rates of heat release, and see if we could fail the column, with the temperature criteria we were looking at. So we did feel the worst case scenario was a fire right near the column. We also, which also drove part of this design, they have an operational plan that limits to a certain extent the types of displays they can have in the town square area. But we did try to use the T-squared fire curves out of NFPA 72, and we were looking at sprinkler response times to see what would happen, what were the ambient conditions after we had sprinkler response. And again, the benchmark criteria we used, the building code says if you're going to have a 2-hour column, it has to withstand the temperatures of up to 1,850 degrees for 2 hours, and then there's failure points on that for temperature, because then, the strength of the steel obviously deteriorates rapidly when the temperatures get above 1,000 degrees. So, Chris?
Two other things going to the level of redundancy that was in this that I recall was, Mike had already mentioned, one was being limitations of use in the area. That was, it's another level of redundancy, just that we brought the level of fuel loading in those areas down, part of the operational plan. And the second thing was, the structural engineer did analyses of, well, what happens if 1, 2, 3 columns fails? What's the effect on the building? If one column failed, does the entire area collapse down upon it, and pile of rubble? How many columns could fail? So and we found, I don't remember the number, but it was several columns, adjacent columns could fail, and the building will stand up as you know it today. It obviously would have some issues with that particular column. And so that was another level of redundancy that we, forget sprinklers, forget the glass, forget the wash. You can lose a couple columns in here and the building doesn't come crashing down.
And even if the building does come crashing down, it's only a one-story building at this point. It's not holding up a second floor.
Yeah.
At that point.
So that's one thing with structural, when you look at a structural alternate method, it was very important for us to work with the structural engineers to look at the system design to see what factors of safety they had employed in the design. Steve?
How did you limit the operation of this?
Well,
designs always include that.
Yeah, and the reality is it creates you an enforcement headache down the road.
So how'd you do with the podium limitations to your life?
Well, predominantly it was the spacing of displays. We knew that they had to keep displays under 12 feet in height, and we tried to space them. We just said reasonable spacing apart, which was probably 10 to 12 feet or more apart.
That included the displays you said had?
Well, sometimes they build these little, rooms. They weren't going to have any of those rooms in here, okay, in this space. If they were, it would trigger a violation of the plan. Now the question is, how often do you get in here to look at it? And that's always a tough thing, and that's what I think is one of the Achilles heels of any of these performance designs, where you make those kind of operational assumptions. Even if we had a higher fire load, we really think with the level of protection that was in this area, that the sprinklers would perform properly and knock that fire down. But we still tried to make sure we could spread things out so we didn't have excessive concentrated loads. So we felt that the design densities in here, I believe what, ordinary hazard group 2 did we go? Yeah, so we tried to bump that up a bit to get a factor of safety in there as well.
If you felt that way, then let's follow it that way. And compel the property owner and the fire department to meet that standard for the next 50 years.
Right.
You have a fire, then the attorney's going to how much were these display cases? Were they 2 inches too close?
Right, and that's exactly the problem trap you walk into with these, and that's why I think with a lot of these systems, if you can put in a factor of safety, you're right, it takes out some of those types of parameters out of the equation. The biggest place we're going to talk about in a few minutes, that we also have smoke control systems, and again, we're trying to minimize the use in the space when we start using design fires for the smoke control system. It's a really weak link of this whole process. So if we can design with factors of safety to take some of the human element out, it's better. But the problem you get, particularly when we get into smoke control, the numbers are so punitive now that every design team just kicks and screams at the size of the systems. A long time ago, they were 4 to 6. They're changing now in smoke control. Did you have any other comments, Ben, on the structural aspect?
Is that what we were talking about?
Yeah, I guess so. We kind of went over.
Go ahead. Let's,
Okay. That was just those. I wanted to talk a little bit about smoke control. And again, we were treating the gallery spaces as a mall. And again, this is a busy slide, but okay. The Barnes building did not have smoke control per se, but we did have 3 openings here in this firewall that we were going to create an airflow of at least 200 feet per minute. And depending on the scenario, the air might come into the Barnes building or go out into the expansion project. And again, the idea was to restrict the spread of smoke and toxic products of combustion. And 200 feet per minute came out of some of the SFP authoritative literature and NIST information that we knew we could at least impede some of the smoke spread. Now, in this gallery space, we used a purge method with 3 fans, but we were purging that gallery just like we would an atrium. And we would provide makeup air either coming from the Barnes building or select points in the space so that we could keep a theoretical smoke layer height at least 10 feet above the exiting people so that they could get out. And that's the intent of the smoke control system, to provide tenable egress and keep this theoretical smoke layer height above the exiting people. And again, the design fire loads you look at are anywhere from 2,000 to 5,000 BTUs per second. We used an axis-symmetric fire, and we felt that would get the most entrained air into that. And again, Steve, it comes up to that same question. You know, we use some of these operational plans to try to curtail some of the fire loads in the space.
Does the smoke control system slow down the operation of the spring?
You know, that's a good question. I was out on a project on the left coast, and Steve Gentleman from FM Global brought up that same question on the life safety smoke control system. Were we venting all the convective gases and the heat that we would need to set off the sprinkler system? And we felt that that would not be the case. However, I think that's going to require closer scrutiny in the future. That was an interesting question.
You're using that to protect where you don't have passive
Right.
anymore. So I mean, it's just slowing down the operation of the protection of the glass and the steel. I think not be an issue.
Yeah, I mean, it's something that I probably would think would require further study. But what we found in this analysis is that the system is going to go off quite readily. I think if we got a fire that was to that size and would start setting up that many sprinkler heads, I mean, I think we probably want to do some CFD modeling on that in the future. But no, that's a good question. I think it was something that we looked at this point, let's get the people out, and then if the sprinklers start to discharge, we had a fire that was large enough now that we had hopefully people out of that area. I mean, it's an interesting problem because it's the second or third time now that question has come up. I think it's something we ought to take a closer look at in the future. I have a code requirement that says I need smoke control and using an exhaust method, and then I have the requirement to sprinkler the
Right,
space.
it's not like you're sucking out, you're keeping it to a specific
Right.
layer. So there is going to be a thermal layer of it,
Correct.
ceiling level,
Right.
setting it off, but
Right.
whether that's enough to reduce the temperature of the ceiling, I guess I don't know.
Yeah, you see, and quite honestly, you know, I think that would, you know, you could do some CFD modeling or some testing, but I think it's a valid concern. I mean, we see the same issue when we do warehouses with, you know, high pile storage. I was asked on a project, can we put a delay factor into the smoke control system? Just like we do with, work on warehouses here in Minnesota, we have a 5 to 10 minute delay before that smoke exhaust system kicks in for a warehouse. Now, a warehouse is not a life safety system, but they were looking for that delay so we could get sprinkler activation and make sure we weren't venting the hot gases that were like thermal suppression. Right, right. But even in the warehouses, they allow that, they want that same delay even with control room. Yeah.
Can you give us maybe an idea as to what that 200 feet per second actually means in real life? What do you feel as far as wind velocity is concerned? And I'm only bringing that up because many years ago when the first smoke tests were done in stairways and they started putting these real big fan systems on, people couldn't open the doors anymore.
Right.
So, I mean, it's nice we have the smoke out, but you can't get the door open. So
Right.
what happens here is that...
This is probably like 5 miles an hour. That. I mean, it's
going to be, if you fill it, it's probably a little too strong. When you're, of course, the smaller these openings, the faster it's going to go. You're staying in these big openings. If it's 200 feet per minute coming through that opening, if you feel a breeze coming through there, it's more than 200 feet per minute. you're not moving a whole lot of air to 200 feet per minute, but it's still enough to overcome that smoke migration across that zone. So in real life, what does 200 feet per minute mean? It's not much,
Right, it's nothing that you're not going to be able to control.
Right, we're doing a project in Oregon, and we're sending makeup air down through some corridors, and it's coming out about 800 feet per minute, so it's a 9-foot corridor, 9 foot high by about 4 feet tall, and we calculated that the air velocity coming out that corridor was maybe 8 miles to 10 miles an hour. So yeah, you would feel, it's not like the Metrodome where you get blown out of those places, but you do bring up a point on the stair towers, because that was also part of this. All the stair towers in the expansion, being a high-rise, had to be pressurized, okay? And they have to be pressurized to 0.15 inches of water column with doors closed. And then you brought up the other point, you got to be able to open the doors. I don't want to blind somebody. You have to be able to open the doors, and there is a code restriction that you cannot exceed 30 pounds door opening force on those doors. So you have a balancing act. You have to maintain the pressure target, plus be able to open the doors. Now, I didn't mention it tonight for the sake of time, but we had one pretty elaborate stair tower that came down in the center that had shutters that would close and close the stairway, and then we would pressurize it. And again, that did pass the tests when we did special inspections. I'll let Ben talk a little bit more about that as well, but we did have to pressurize the exit stairs because it was a high-rise. So we had all three of the smoke control methods that code prescribes in this building. We had the exhaust method, which is purging the gallery spaces. We had the airflow method, and we had the pressurization method in the stair towers. And because of that, those systems required special inspections, and the special inspections are spelled out in chapter 9 and 17 of the building code. And there was very specific things you have to go through, including field observations, review of the design intent, and then the systems performance testing, and coordination with all the different contractors, because they were all a part of this smoke control system and what made it work. Special inspection, Mountain Star did the special inspections. Now, Ben was involved with that as well, and I had to subcontract out part of the additional special inspections, because I was predisposed, and I was studying healthcare. Unfortunately. They did a great job. We were contracted to do the special inspections, not only on the smoke control, but also the equivalencies that were proposed to the building.
How often will these have to be inspected and operated?
Annually. It dovetails just like sprinklers and fire alarms. They're minimum annually. And I think we could talk about some of the lessons that were learned on some of this. Ben, maybe you were out there in the field. Gordy, you were out there to witness some of this. Bob, you were there as well. What are some of the things you saw during when we were commissioning or doing the special
I
inspections?
saw those three guys.
Yeah.
They're from the city.
Ben, what were your comments from your view of?
We have a couple of them up there that I think go hand in hand that came up again and again on this project, and you on every project. This one in particular illustrated the importance of documentation, communication, and integration. We have all of these different contractors coming together to make one aspect of this massive project come together. Sprinklers, fire alarm, building controls. You've got Mountain Star over here with some idea of the way something should go. Mechanical engineers with an idea of the way that they thought the smoke control was going to go. And we all had to come together, and then in the meantime make the city happy. Gordy on one hand, but Gordy wasn't the one out doing the inspections. And we have one inspector on this job for the sprinklers. Again, maybe the inspector that was dealing with the sprinklers wasn't privy to all of these communications that were going on behind the scenes. We talked earlier about during the mock-up. Well, we saw that we needed to change something, maybe turn the deflector a little bit. Well, the inspector wasn't there. He comes out and, what are you doing? This is a horizontal sidewalk. You've got to point it down, and by the time you've got to turn sideways to the beam. What are you doing? communication is key in these things. From the contractor side to the code official side, communication, documentation, and to get all of these sides together. I think that was one big thing on this project, and it will be again and again along with these projects. One other thing for both together contractors and the code officials too, these complicated systems aren't going to work the first time, the second time, the third time. We'll get a lot of these complicated smoke control systems going, or even things where we have to integrate smoke control, sprinklers, building controls. It's not going to work the first time. Everybody take a breath, relax. We'll get it figured out.
Problem is, we always have to get these things online at the 11th hour. You know, it's no different, I think, than anybody, whether your sprinklers or fire alarm. I think that some of the integration things, just going through the fire alarm matrix with the building control sequence, I don't know, Bob, how many times we went through the matrix and updated it, revised it, refined it, how it interfaced with building controls. Quite elaborate, quite extensive. And the other thing, we wanted to make sure the owner understood what he was getting and when the system was reacting and how it was performing. So I thought that was extremely important. And with that documentation, after we're all gone, you know, we have to have a paper trail somewhere because we've made all these design assumptions. And Bob's already told me they've already made some adjustments to the system, and it's only been open since last spring. And those are the realities of those type of things that happen. I think the importance of the mock-up testing, we started learning that when we did the convention center expansion. When we put that deluge system on those large trusses in there, we knew that the types of nozzles and positioning was important. Likewise here, seeing is believing. You know, we can do all the modeling and say all we want, but until you actually see some of this in action, it really helps you come up with a much more improved design. And as Ben mentioned, the communications, whether it's the design team, the contractors, the code officials, the fire marshal, we have to keep everybody on the same page. In a project like this with so many variables in it, you know, you really had to stay on top of it. And again, special inspections, you're going to continue to see that be very common. The code requires it for smoke control. You're going to see that continue as people are putting those types of systems in buildings, and when you see performance-based designs or alternate methods, it's very common as well to have a special inspection done to make sure that whatever was developed in the design and analysis report is implemented in the field. And that's the one thing that really, out of all of this, that always I worry about, is that taking those concepts that you have developed and analyzed and made recommendations for and gotten acceptance by the jurisdictional authorities, and getting those translated into construction documents without losing the spirit and intent and the guidelines that you put together. Because it's interesting to see what you put on paper back 4 or 5 years ago, and hopefully seeing that it's out there in the drawings that have been produced for construction and getting installed in the field. And without that kind of diligence going through that and making sure that that is in compliance, these designs are vulnerable. And that's the biggest worry I have when sometimes if we're on a project as a consultant and we're not there all the way through, we can't always tell you if the things we put in the way we had crafted it together. So whether it's whoever the engineer of record is for the analysis, it's important that they or an able third party gets to see this thing through. These things happen. Any questions?
One of the interesting things that you find on a project of this size, especially with smoke control, is that the electrical engineering community and the mechanical engineering community don't talk the same language. And so when we first looked at this, the smoke control system was supposed to be a UL 864 system. And we were to give just a data stream from the fire alarm to the energy management system, and that's what happened. Partially, so of course I didn't have smoke control in my proposal, so 6 months into the project, we said, well, it's not UL 864, so the fire alarm had to go to smoke control. So it became very critical for all the parties to get together. We had 56 revisions of smoke control before we finally came up with one that everybody agreed on. So and and you'll find this even now.
Yeah.
You can have the same engineers sitting in the same building, and they still don't understand it.
It'll happen on the next project with the same
I know,
design team.
I expected that.
Yeah.
I didn't know we had to have copper tubing on the pneumatic dams.
Yeah, oh, yeah.
We told you on the last.
Third party review, well, as part of our special inspection. Yeah.
Can I ask if anybody got this done within the estimated hours? Oops, sorry.
I think it was only a year over.
Yeah. So, we'll let you get going, but if there's any other questions, we'll be here for a few minutes. But again, it was a collaborative effort of many people that we put together from our firm, working with the city, working with the contractors, and the designers. This was a fairly complex building, but it took everybody to put their heads together to try to satisfy an owner who wanted a very distinct design. Gordy, Ben, and I were at the opening of this thing, and we knew this was a unique design when the executive director got up and said, when we first designed this building, we wanted a building that that they could go in any corner and they use the F in Irish. Fornicate in any part of the building. And Ben whispered in my ear, he said, well, that was the word I'd use, but not in that context. You're swearing all the way through the process.
The only ones that get fornicated were the network.
Right, yeah. So I appreciate your patience and we tried to condense 5 years of work in a very short period of time, but there's plenty of other things that went on here, but it's a fascinating building. You get over there, I guarantee you'll have an opinion of the design. You'll either like it or you won't. So, thank you very much.
I'd like to thank Mike and Ben for a very interesting presentation. You're supposed to do one of these a year, so we can have you back every year. Remember, next year this time?
We'll do the water park.
Oh, okay. Okay. We'll see everybody back hopefully next month for next month's presentation. And thank you very much for everybody who was here tonight.